Hi, this is Dr. John Bergduff. In this video, we're going to talk about adding integers. And there are just many wonderful illustrations and manipulatives that help students understand the properties and rules for adding integers. I want to just show one of those in this video, and that's the use of a number line. So let's start with something super simple that involves only positive numbers that everyone will feel comfortable with. 2 plus 3. On a number line, and let's start with a 0 here. 1, 2, 3, 4, 5, and some negatives as well. Oh, sorry, that's sort of sloppy. We can visualize 2 plus 3 as starting at 0 and skipping 2 units to the right, followed by another 3 units to the right. Actually, in some schools, they have these number lines drawn on the floor so students can stand at the 0 and move 2 steps forward, 3 steps forward, and see that when they add 2 plus 3, they're going to get 5. What if we have some negative numbers involved, though? What if we're looking at -4 plus -1? I'm going to try to draw my number line nicer this time. Let's see if I can do that. -5, -4, -3, -2, -1, 0, 1. That will actually turn out to be okay for this one. With negative numbers, the arrow moves instead of to the right, to the left. So if I want to illustrate -4 plus -1, I start at 0 with the first number, and I measure an arrow that goes 4 units to the left, and then 1 more unit to the left. And so -4 plus -1 is -5. Now what a student might call the numerical part of that answer, looking at just the 5, is 4 plus 1. We can say that using better terminology. If you consider the absolute values of the two numbers you're adding, the absolute value of -4 is 4, the absolute value of -1 is 1. To add these two integers, you add the absolute values of the integers, and because they're both negative, the sum is negative. And that works just fine until you start mixing positive numbers and negative numbers together. What if we were going to add 4 plus -3? Again, I'm going to draw a number line here, attempting at each chance to make them neater and neater. Okay, I'm getting a little better. A positive number represents an arrow to the right. A negative number represents an arrow to the left. So if I were going to add 4 plus -3, I'd have to start at 0, go 4 to the right. Then I would have to go 3 to the left from there. And that means that I will land at a +1. Now that seems to be causing a problem with what looked like it was going to happen. It looked like we would just add the absolute values of the numbers, but this time we don't. If we added the absolute value of 4 and the absolute value of -3, we get 7. This time it looks like we subtracted them. Let's do a couple more. Let's try -5 plus 2. So I'm drawing a number line here. Want to get some room for some negative numbers. And maybe extend that just a little farther. There we go. -5 plus 2. So the -5, we always start at 0. -5 would mean our arrow goes to the left 5 units. oops. And then it would go 2 units to the right. So from where we ended up, go 2 units to the right, and counting that carefully, that means I end up at -3. So -5 plus 2 is equal to -3. Now it's beginning to be clearer what's going on. Somehow that 3 is the difference between the absolute values. The absolute value of -5 is 5, the absolute value of 2 is 2, so 5 minus 2 is 3. However, in the first example, at the top of the page, the answer turns out positive, and in the second one it's negative. And one would be tempted to say, oh, in fact, you'll hear people say this, oh, you subtract the absolute values and then give the answer the sign of the bigger number. The problem with that is if you look at the second example and ask which one of those numbers is bigger, well, the number that's bigger is farther to the right on the number line. 2 is bigger than -5. So if we were to say give the sign of the larger number, it should be positive. What we need to say actually is to give the number the sign of the number that is larger in absolute value. Okay, let's do one more example before we try to summarize all this. I needed to clear the screen, but here are the answers to the last 2 questions that I asked. Let's do one more on the number line and then see if we can summarize. So suppose we're going to do 3 plus -5. So while I'm drawing this number line, think about what you think you should draw, remembering that we always start at 0, and then the numbers in order tell us which arrows we should draw and in which directions. So be thinking about what we would do to represent 3. 3 would start at 0, and I'd draw an arrow that moves 3 units to the right. And then -5, I would start where I left off, and I'd go 5 units to the left. Where I end up would be -2. 3 plus -5 equals -2. Looking at that answer, it looks like what we're doing again, when the numbers have opposite signs, we subtract their absolute values, and the answer takes the sign of whichever number is larger in absolute value. And that happens to be the -5 is larger in absolute value, so the answer is negative. Now, drawing the number lines is wonderful, and it's a great way to illustrate the properties of addition. Once we get comfortable with that, we can settle in on some definite rules. And here's, I think, a good conclusion to what we've seen. Adding integers. If the signs of the 2 integers are the same, add the absolute values of the integers and give the sum the common sign. A couple of the examples that we had done earlier, we looked at 2 plus 3. Those are both have the same sign. They're both positive. So you add the absolute values of the number. Absolute value of 2 plus absolute value of 3 is 5. The common sign is positive, so the answer is positive. Another example we did was -4 plus -1. These also have the same sign. If we add the 2 absolute values together, absolute value of -4 is 4, absolute value of -1 is 1, 4 plus 1 is 5. But we give the answer the common sign. They're both negative. So this is what we do if the signs are the same. Add the absolute values and give the sum the common sign. If the signs of the 2 integers are different, subtract the absolute values of the integers, larger absolute value minus smaller absolute value, and give the difference the sign of the number that is larger in absolute value. And that's that very important observation we made. So if I look at a couple of the examples we did on the number line, 4 plus -3, these numbers have opposite signs, subtract their absolute values, 4 minus 3, larger minus smaller, that would give you a 1. The number that's larger in absolute value is the 4, so we give the answer a positive. Negative 5 plus 2, opposite signs, subtract the absolute values. Absolute value of negative 5 minus absolute value of 2. 5 minus 2 is 3. Give the answer the sign of the number that is larger in absolute value. The negative 5 is larger in absolute value. It's not the larger number, it's the number that's larger in absolute value. And finally, we had 3 plus negative 5. Try to squeeze that in there. Again, opposite signs, subtract the absolute values. 5 minus 3, and the number that's larger in absolute value is the negative, so the answer will be negative 2. So I hope this video helps you see how cool number lines are to illustrate adding integers, and how a few examples lead very easily into sort of the standard rules that eventually we want our students to be comfortable using. Thanks very much.